All right, let's start with a couple of announcements here. First of all, your next homework assignment is due on the 18th, so that's a week from today. And I wanted to remind you that quizzes in this class are often unannounced. You know, occasionally I'll give you a heads up about them, but you know, quizzes can occur at any time. And so, for instance, on Thursday, where I've asked you to bring your computer to class, it's very possible that if we had a quiz that day, it would be something that you'd need a computer to solve it. And so if you forgot to bring your computer that day, then you may not be able to solve the quiz. And it's not required for you to own a computer necessarily. Of course, you can borrow one from a roommate or somebody who's in a different class and isn't using their laptop during this hour. And in addition to that, there are laptops available for checkout from the library. If you want to go over to the Morrow Library, they have a limited number, but usually it's possible to get one this early in the morning. All right, so any questions about those announcements? Okay, now we're getting to the point in the class where you're going to be submitting some of your work that you did on a spreadsheet. And I think so far it's been going really well with you creating PDFs of your handworked solutions. But from here on out, some of the stuff that you submit will be Excel. And so I wanted to show you how I hope you will submit your work in Excel. And the thing that makes it tricky in Excel is that some of what you're doing isn't visible to the grader necessarily. So I give you instructions on the homework assignment what you should do, and that is you should print out a copy of the spreadsheet and create a PDF of it, just the same as all the other PDFs that you've been making. But you should write little notes on your PDF of the spreadsheet to help the grader understand what you did. So for instance, here I pasted the given cash flow diagram into my Excel file. And you know, here's the solution, and I'm explaining what some of these columns are. You know, for instance, that this column was just given data, and I'm explaining this column years until year 16. I say, for instance, you know, what it is and how it was calculated, like what was the formula for that. Down here I'm indicating that this column of data was just given. You know, here I've labeled. All of these columns have labels. And I'm explaining here where I'm doing the sum function, the sum of the future values, and I explain what that is. And then I clearly indicate the final answer with my handwritten notes here. In addition to having it on the page, you have to really draw attention to what's the final answer, because everyone is going to solve their work a little bit differently. And so you shouldn't put the grader in the position where it's like a treasure hunt, where the grader's trying to find, okay, where in this solution is the answer that the question was actually asking. And I've told the grader that it's not her job to find the answer in what you submit. It's your job to clearly identify the solution and make it explicitly clear what you did and what's the answer to what's being asked. And so this is posted on MU Online if you want to go back to this and refer to, you know, how was it solved. So just to summarize, you'll continue to make your own PDF of the work that you've done, and then in addition to that, you upload your Excel file to MU Online in case there are any questions and the grader needs to get into the Excel file itself. All right, so any questions about how to submit an Excel file for the homework? All right, if you want to discuss it with me, you have some lingering uncertainties, please feel free to stop by my office. I'd be glad to talk to you about it. All right, now we're moving into chapter 3 in the book, where we're going to be discussing how to use spreadsheets to solve some of the questions that we've already looked at. And the nice thing about the spreadsheets is they'll enable us to kind of handle more complicated questions than it would be convenient to solve by hand. So let me introduce you to one new idea before we start working on the spreadsheet stuff, and that's the idea of cash flow balance. I just added this slide yesterday, and so it doesn't appear in the PDF of the notes that you may have printed out. But you know, this illustrates the idea of balance, where all of the weight on one side is balanced by all of the weight on another. So here's another just illustration of balance. Now, from an economic perspective, here's what balance looks like. It's where the present value of the inflows are equal to the present value of the outflows. That's one way of illustrating balance. And so what we're saying is, if you made some investment in the present, then the return you receive of inflows to you over time is equal. All right, so for this cash flow diagram that I've got on the screen, is that in balance? Do the inflows and the outflows balance out in this cash flow diagram? Why not? Okay, so there's 1, 2, 3, 4, 5, 6 payments of $5,000. So that means we received $30,000 and the payments were $23,000. But when are the inflows? They're in the future. So is this $5,000 in year 6 worth $5,000 equivalent dollars in year 0? No, because of inflation, because prices are inflating. The value of that future money isn't the same as the present value money. So it's not just as easy as saying $30,000 is more than $23,000, so it's not in balance, because we have to consider the timing of it. So back to the original question, in this cash flow diagram, is the present value of the inflows, is that equal to the present value of the outflows? I can stand here all day. Very good. Yes, exactly. He's nailed it. So he says, now wait a minute, there's something missing from this cash flow diagram. It's the percentage. And so the only way you know if it's in balance is you have to know what interest rate to discount those future amounts to the present at. So without an interest rate, we don't know whether there's that equilibrium that we're looking for. Now the reason why I point that out is today we're going to be solving for an unknown interest rate. And it's going to be an iterative process. We're going to try some guess value, and then we're going to check. We're going to say, well, with this guess value, is everything in balance? And it won't be with our first guess, but we're going to keep changing the I until the present value of the inflows is equal to the present value of the outflows. And by doing that, it'll tell us what is the rate of return of an investment. That's a solution strategy, is you look for everything to be in balance because the interest rate that causes it to be in balance means that the inflows and the outflows were equal, and so that's your rate of return for a particular project. So it all depends on the interest rate. Does everybody understand that idea? This is really the essence of the course. And so if this is fuzzy to you, it's critical. It's absolutely critical for you to master these concepts. And so it's really important for you to read the textbook, to come see me in my office if you have questions. It's really critical because everything else builds on the next couple of classes. And so if you get lost here, you're never coming back. But if you have a solid foundation on this material, then you'll be okay through the rest of the semester. All right. So we're going to do an in-class exercise where we're going to be solving for an unknown interest rate, where we're given an initial purchase price for some equipment, and we know that that equipment is providing income for a certain time horizon. But we want to know what's the rate of return. So this person, when they buy the equipment, there's an opportunity cost associated with buying the equipment. Anybody remember, just as a point of review, what is opportunity cost? What you miss out on. Good. It's what you miss out on, or it's the value of the second best alternative. So this contractor could have taken the $60,000 and put it in the bank. But that's not what they did. They invested in the equipment, so they want to find out, well, what was the equivalent interest rate that I earned by doing that? Okay, so follow the bullet points. First of all, draw the cash flow diagram for this, and then I'm going to start up Excel on my computer, and I'm going to demonstrate how we can solve for the interest rate. All right, I see that most of you have got this figured out. These cash flow diagrams should be negligible at this point. Just translating the word problem into a little sketch should be your first instinct when you have a problem, and it should be really simple for you. So we have an arrow down, and we've labeled it as P because this is at the present, year 0. There's an expenditure of $60,000. And then 10 consecutive, uninterrupted, the same amount revenue. This is an A, an annual series, sometimes also called a uniform annual series, where the inflow is 16,000. And you see that here I've labeled I equals question mark. And that's an important part of the summary as well. It tells us what's the unknown here. We're trying to find out what's the interest rate that brings this all into balance. All right. So I'm going to show you two methods for solving the interest rate. The first is kind of a manual solution that uses the formula P equals F to 1 plus I to the negative n power. And we've seen this plenty of times before. It's in that table of formulas that I've provided for you. It tells you how to discount future amounts. Remember, the word that we use is compounding when you're moving money into the future, and it's going to get bigger. Discounting is when you're moving future money backwards in time, and it makes the amounts get smaller. All right. So let's start up Excel if you haven't already. And the first thing you should do is save your file in case your computer crashes, and also so that you can come back to it later. This is going to be useful as a resource when you work on your homework assignment. So save this someplace you know you're going to be able to get to it later. I'm going to call this I7. All right, so we want to start off I7 problem 1. Let's put in I equals, and we have to put in a guess value for the interest rate. Remember I said that this is an iterative problem where we start with some guess of maybe what the interest rate is, and we have to keep changing it. So let's just say initially 0.01 is my guess, 1%. And we'll come back and fix that later. So we're going to have a column that's year, a column that's amount. Let me make that a little bit bigger so it's easy to see. Year, amount, and PV of amount. Okay? So this cash flow diagram has 10 years, so type in 0, 1, 2. And remember from Engineering 111 that once you have a trend, you can click in this corner and drag it down, and it will continue the trend. So you don't have to type in all those values. So 0, 1, 2, and I click and I drag until I get to 10. All right, amount. In year 0, we have negative 60,000. And then all the rest of them is 16,000. And I don't have to type that over and over again. Remember, all I need to do is click in that corner location and drag it down, and it will fill all the rest of them with the same 16,000. So here I'm clicking and dragging. By the way, I'll remind you that if you fall behind in today's activity, I'm recording this, and so these YouTube videos it's especially useful for the computer stuff, because I find in my past experience that some people are really quick with Excel, some people are less familiar and need to see it more than once, and so just keep in mind that the recordings are there, so don't panic if you fall behind on a certain thing. Okay, let's format this so that it's showing up as currency. So highlight the amount column, and where it says PV of amount, highlight it and then do, instead of general, let's say currency, and then reduce the decimal point, decrease decimal, because I don't need to see those pennies. That's just useless information. So I'll decrease it so it only shows the amounts. That's an optional step, but it just, I think, looks a little bit better when it has the dollar signs there. Okay, so now for PV of amount, we're going to use this formula, P equals F times 1 plus I to the negative n power. So the amount that we're trying to move from the future to year 0 is whatever amount is in a given row. So we're individually discounting each of these amounts, however many years is in the row. And so this is going to move 0 years because it's already in year 0. This 16,000 is moving from year 1 back to year 0. So it's only moving 1 year. So this 16,000 in year 1 is going to have a greater value than this 16,000 in year 10, because this amount in year 10 has to move back so many years, it's not really worth very much in today's terms because it's paid out so long in the future. All right, so let's do the formula. Equals, click on the amount, times 1 plus, and now instead of typing in the interest rate, click in the cell location where that interest rate is, and then press the F4 button, and it'll put in dollar signs. Who remembers back to 111 what those dollar signs are for? Right, it's an anchoring or a lock so that when you drag the formula down, it always looks in the same spot. We don't want it to be a relative reference because we're going to be applying this formula row by row, and we don't want it to be changing. So you either have to type in those dollar signs if you have maybe a compact keyboard, or you type the F4 button. All right, so 1 plus I, we close it, to the power of negative n. And n is whichever year we're on. Okay, so I'll leave that formula up for a moment so you can take a look at it. Now, when I type enter, what should be the result of that calculation for year 0? 60,000. It's going to be the same amount because it's moving 0 years. So if it's anything other than 60,000, then Houston, we have a problem. All right, so, okay, negative 60,000. That's good. Now, what I can do is all I have to do is drag that down to all the rest of the rows, and it should tell me the present value of each of those future amounts. And in fact, I don't have to click and drag. All I need to do is double click in that corner where the thick green box is. So if I double click, it'll apply that formula all the rest of the way through. Okay, so just in summary, why are all of these amounts different if it started out as 16 and if we're using the same I? Why is the present value of each amount not the same? Okay. Yeah, why is it decreasing every year? Why isn't it the same amount? It's because of the n is different. Like if you think about the formula, F is the same. F is the 16,000. I is what we put in here. So what's changing is the n. So this 16,000 in year 10, if you want to pay me $16,000 10 years from now, what that's worth to me today is $14,485. That's what it's worth to me today if the interest rate environment is 1%. So money that's not so far in the future is worth more than money that is far in the future. Does that make sense to everybody? Is there any questions about the main idea before we just delve into the mechanics of the spreadsheet? Because it shouldn't just be about click here, type this. It can't just be parroting some process that's on the screen. It has to really represent something that you understand as well. Yeah.
Oh, look, the last 60,000 is only showing like positive 60,000.
Did you put negative in the amount?
Yeah. Like if you click on it, like it'll show like the negative, but once I add it up, it's not going to say positive 60,000.
Well, I don't know. I'll have to, oh, in parentheses. Okay, that's because you didn't change the cell formatting. Parentheses means negative, like in the accounting format. So if you highlight the money and you do home and you click on currency, then that'll change that parentheses to a negative number.
Okay.
Sometimes it also puts amounts in red in Excel to indicate like a negative amount. So if you see it in red or the parentheses, it's one of the accounting ways of saying a negative number. So you either need to change it to general, which will put that negative sign there, or currency. Highlight the cells that you want to apply that to. Was there another question over here? All right. So now we need to add up, because if we go back to this, it says the sum of the PV of the amounts are equal to 0. That's what we're looking for. We're looking for some sort of a sum. So let's say sum, and then do the formula. We want to add up all of these amounts together. So equals sum, and highlight all of those, close parentheses, enter. Okay, so our criteria is we're looking for the sum to be 0. That's how we know we've identified the right interest rate. So did this person earn 1% interest? No. Right now, since this is positive, that means that we've underestimated the rate of return because there's more inflows than outflows. So let's see if changing it to 2%, what that does if it gets it closer to 0. So what our operation is we're going to be keep changing I values until this amount is equal to 0. That's what we're going to do. All right, so let's see if 2% gets us closer. 0.02. Yes, we're headed in the right direction. 0.03. 0.04. Now this is getting tedious, typing this in over and over again. 0.05. We're still heading in the right direction, but I'm getting bored. Anybody remember a way to automate this? Dusting off your skills from 111 last year?
Solver.
Yeah, you can use Solver. You can use GoalSeek. So let me remind you about GoalSeek, since it's the simpler of the two. If you go to the Data tab, Data and What If Analysis, and GoalSeek, our goal is we want the sum of that to be 0. So GoalSeek, okay, so set that cell to the value of 0 by changing the interest rate. So set the sum to 0 by changing the interest rate. That's what we've been doing manually. Click OK, and in about half a second, it'll try a bunch of little possibilities for the interest rate, and it will find which one of those interest rate possibilities gives us a 0 sum. All right. So the answer is this project yields a return of 23.4%. And that's the answer. Here, let me make it clear that that's the answer. Okay, what questions do you have? Any questions? Which formula?
The one that put in for negative 60,000.
Yep, this one here. In fact, I'll do better than that. I'll just type it from scratch. All right, so the formula is equals, click on the amount because we're doing F. So the future value is this given amount times parentheses 1 plus, click on the location for the interest rate, so 1 plus I, close parentheses, to the power of, to the power of n. And we need to make sure that we put in those dollar signs for the reference to the interest rate, and it needs to be to the negative n power. So I'll put in the minus sign there. Okay, so that's the formula. And then drag it down. And since we've already got the correct interest rate in there, then the sum of all of those above amounts is equal to 0. All right, so in the handout that you've got, the in-class exercise I gave you, the unknown rate, where it says what rate of return did the contractor realize on the investment, the contractor earned an interest rate of 23.4%. So back to the idea of opportunity cost. Was it better that the contractor put the money into this investment rather than into a savings account? Oh, absolutely. $60,000 in a savings account, you'd maybe, if you really searched, could find a savings account that would pay you 2.5%. But this person has earned 23% on their investment by putting it into some equipment instead. So good job to the contractor. So that is one method where we found the sum of the PV of the amounts. Let me show you another approach. It says here that the other approach is a function that's called equal rate. That's the function. And so here I'm going to say rate, just to label my answers, you know. That's not the formula. I'm just labeling what is going to be in the side of it. Okay, now here, the function that we're going to use is equals rate. And as soon as you put in those parentheses, it starts prompting you what you need to fill in. So first of all, it says NPER. What that means is the number of periods. So in this cash flow diagram that we were looking at, how many periods are there? 10 periods. All right, so I'm going to type in the number 10, and then a comma, and then here it says PMT. Now in Excel, that's the abbreviation that's used for a recurring amount. They call it payment, but it just means like the regular amount that's always the same. So in our cash flow diagram, what's the recurring amount? The one that happened over and over, 16,000. Good. So I'm going to type in 16,000 without the commas, just the 16,000. And then I put in a comma to get to the next field. So now it's asking PV. What do you suppose that means? Present value, right. What was our present value? Close. 60,000 is the absolute value of our present value, but we need to indicate the magnitude, the direction of it as well. So we need to put in minus 60,000 because that was an outflow. That person was contributing the present value. So here where it says PV, we're going to put negative 60,000, close parentheses. All these other things that are in brackets, that's an optional thing that you can tell the computer. We don't have a future value in this problem. And type is referring to whether the payments are at the beginning of the year or at the end of the year. And the default assumption is that the payments are at the end of the year, so we don't have to put anything for that. And then here it also says you could give it an initial guess, and then it would be able to solve for the rate more quickly. But this is a pretty simple calculation anyway, so it doesn't speed things up that much by providing an initial guess. We don't have to. All we have to do is put in these first three terms: the number of payments, the amount of the payment, and the amount of the present value amount. Okay, so I'm going to close that and type enter. 23%. That's pretty close to what we saw. And the reason why it's not exactly is I just need to increase the digits here, and it'll be exactly the same. So 23.413, and there was more digits if I chose to reveal them. So it solved for the interest rate. It did all of those calculations that we did earlier, kind of internally, behind the scenes, and calculated the interest rate. So it's a pretty useful function. You have to know how to do both. Sometimes I'll ask you to do it manually, finding the present value of the future amounts and summing it up and looking for balance and equilibrium. Sometimes you'll do it that way. Sometimes you can just use the rate function. Any questions about either of those approaches, the rate function or the present value of the future amounts, summing it up? So just to reiterate, here is the, by the way, what do these two pictures have in common? They're both at the beach. I'm glad we're not at the beach today. I think they're going to get hit pretty hard with the hurricane that's coming. Maybe a different beach. All right, so this rate function can be used to find present, it can be used to find the interest rate including a present value, or if you had a single future value and you wanted to find out the equivalent interest rate, you could use that function for a future value as well. So for instance, if your cash flow diagram had an annual series where maybe you were making payments, recurring payments, and then you were going to take a big withdrawal at the end. So this would be the future value, and these would be the payments. You could find the interest rate that way as well. You know, if you're making deposits, then you're going to take it all out. And there's a note here. The amounts in each function must have an opposite sign. And so opposite sign, we're reminding you that, you know, sometimes you're making deposits, sometimes there's withdrawals, and so you need to account for that in the equation. Like, let's see what would have happened in here. What if I forgot that negative sign for the 60,000? What if I just typed in 60,000? What happens if you forget it? Well, it can't calculate an interest rate because there's no balance. And this is all about balance. The inflows and the outflows are equal. And so it's saying problem because there's no balance. The only way there's balance is if there's both inflows and outflows. All right. Okay, question 2 in the handout that I've given you. Unknown N. A contractor purchases equipment for $60,000 that provides an income of $8,000 per year. The interest rate is 10% per year. So that's already given. But what we want to do is find out how many years until the investment breaks even. In other words, this person is going to be getting $8,000 over and over and over. So how long till the equipment is paid off and the contractor actually is beginning to earn profit? Okay, so there's an A, B, and a C. The first step that I ask you to do is define which one of these numbers in the problem statement is the A, which is the P, and find the ratio. Step B is look at the 10% table that I've provided. Let me bring that up on the screen. So here's the 10% table. And so find what is the ratio of A to P. Okay, so of course, in this one, A is 8,000. So A equals 8,000. P equals 60,000. And so A divided by P is 8,000 divided by 60,000. And so that number is 0.1333 continuing. All right. So now go to this table, the 10% table, and find the column that says A/P, capital recovery. Okay, so there it is. And go down through the numbers and look which one is closest to 0.1333. So now here's one that's a little too high, 0.135, and then the one below that, 0.131, that's a little too low. So what that tells us is that actually after the 14th year, during the 15th year, that contractor receives enough revenue that the investment is paid off. So the way that you'd write the answer there is that break-even occurs in the 15th year. That's how we'd put it.
Could you use interpolation to get that even more accurate?
Well, that's a great question. So he's asking, can you use interpolation to get it more accurate? And the answer is, the payments only happen one time each year. And so it's sort of like we can't know like to a decimal number of years because the payments just occur once a year. And so in the 14th year, this contractor hasn't achieved break even, and in the 15th year, it's break even plus a little bit of profit. So, I mean, numerically, you could find some like 14.38 or something like that, but it really wouldn't be physically meaningful since the payments are discrete. Okay, so let me show you the Excel solution to this. You know, this is the table solution where what we've done again is we found equilibrium. We found balance. We found the inflows and the outflows are equal somewhere between the 14th and the 15th year. Okay, so go back to your spreadsheet, create another table down here at the bottom, and maybe we'll call this one problem 2, and the other one was problem 1. So I go to problem 2, save my work. Okay, so this is in-class exercise 7, problem 2. And we're given an I value on this one. I is known to be 10%, so 0.1. And the columns I want to have in here is year, amount, present value of amount, and then the cumulative present value of the amount. So how many years did it say this happens? 8,000 per year. Oh, it just keeps continuing. All right. So let's do it through 17 years just to illustrate. So I'll take the years down through 17. And then the amount is that in the first year the contractor pays 60,000. And then all the rest of the years the contractor receives 8,000. All right. And then I'm just going to double click on that right lower corner to get it to fill in all the values as long as there's some number beside it. Okay. And I'm going to highlight all of these places where money is going to be and format it with the currency. So remember that step where you go to home over here, and instead of general, let's have it be currency. And then I don't want to be looking at too many unnecessary significant digits, and so I'm going to decrease the decimals so it doesn't show the pennies. I don't care about pennies, not on this problem. Okay, so this is where we're at so far. As we're looking for break even, we're going to find the present value of the amount. So the formula is going to be the same as it was in that first in-class exercise. The present value is the future value times 1 plus I to the negative n power. That's what's telling me how to discount these amounts at 10%. So the formula is equals the amount, so that's the future value, times 1 plus I, and I'm anchoring that reference by pressing the F4 button so that when I drag the formula down, it always looks in the same spot for I, to the power of negative n. And n is the year that we're on. All right. And then I can double click on that corner and it'll apply the formula all the way down through all the numbers. And so that pattern that we see is expected. You know, the money that's far in the future, it doesn't have as much present value as the money that's just a couple of years from now. The money that's just a couple of years from now only has to be discounted a short period of time. But that money 17 years in the future, if somebody says, I'll give you $8,000 in 17 years, that's the same as receiving $1,583 today if the interest rate environment is 10%. Okay, now this is this cumulative present value of amount. This next step is going to blow your mind. It's the most mind-blowing thing you're ever going to see. All right, so hold on to your hats. If you're wearing a hat, hold on to your hat. All right, so the cumulative present value, for the first year, it's just the amount. Okay, so equals just the number beside it for year 0. Okay, for the next one, I'm afraid I'm going to lose half the class with this. This is shocking. So it's equals, it's the one above it plus the one beside it. That's all. Nobody looks as impressed as I was hoping you'd be. It's probably just because it's early. If you're seeing this in the afternoon, you'd be freaking out right now. But what that does is it says the cumulative amount, just think of it this way, how much is in your wallet? Okay, in the first year, how much is in this contractor's wallet? Well, he just paid out $60,000, so he's got negative $60,000 in his wallet. Okay, what about at the end of the next year? Like, what's the overall picture of this investment? Well, it's the negative $60,000 that he was at last year, plus whatever revenue came in this year. So things aren't as grim. It's down to negative $52,000. But every year, this contractor is going to be getting closer and closer to finally breaking even. So if I double-click to apply that same trend all the way down, you'll see that eventually, between the 14th and the 15th year, it goes from a negative amount, meaning that the contractor hasn't yet recovered the balance, to now a positive amount, which indicates finally there's some break-even there. The equipment is paid off, and there's profits. Okay, so I'm going to delete this and show you one more time what we do for this cumulative present value of amount column. Okay, so for year 0, there's nothing else that's happened yet. So the only thing that's happened was an outflow of $60,000. Okay, but the year after that, we have the previous value cumulative amount, so it's the cell above, plus the PV of amount for this year. So that's the present value of the $8,000. We don't care about the future value of the amount so much as we care about the present value of the amount, because we have to take all of these numbers to the same time frame before we can add them. You can't add $1 17 years from now with $1 in year 0, because those two dollars don't have the same value basis. And so the way to make it so you can combine amounts is take those amounts all to the same year. So that's what we've done here in the PV of amount column, is we've taken it all to the same year, and then we're accumulating to find out how much it's worth. So it's the cell above plus the one to the side of it, and then you drag that down all the way to the end of our time frame here. And then the note that we can add is that after this payment has been received, break-even has occurred. So in other words, break-even occurs after the 14th year in the 15th year. Does anybody want to see a certain thing on the spreadsheet that I maybe went over too quickly? Remember, I'm going to let you keep this in-class exercise paper. The video's on YouTube. So it's just like throwing baseballs or shooting hoops. Just practice. Like you gain proficiency through experience. So if you want to be able to do this flawlessly and naturally in the quiz or on an exam, the way to make sure that happens is by practicing it. And that may seem tedious to do the same thing over again, to solve the same in-class exercise that you already have the solution for. That seems tedious, but it's how you build proficiency, is by repetition. So I'd encourage you, if this feels really unnatural and you're uneasy that you'd be able to do it on your own, try solving it again. All right, so let me give you a warning about what we're about to do next. So until now, we've been typing in this formula manually. As you might expect, Excel has some shortcuts to having to type in the equation manually. It knows about these kinds of calculations, and so it has built-in equations. But there are some tricks with those built-in equations because it has a certain assumption. So here's what Excel assumes when you do the built-in functions. So we're going to do a built-in formula to convert between future value and present value. So if you look at the cash flow diagram, you can see that here's a future amount of $12,500. What Excel assumes is that if you had an inflow as the known amount, Excel thinks, well, it must be an outflow that you're asking me about. It always assumes that if there was a payment one time, then it's going to have to be like a withdrawal the next. So the opposite direction of the amounts. So it assumes that the arrow direction changes, in addition to finding the discounted magnitude of that future value. But here's the thing. Sometimes we don't necessarily want to solve for what deposit today is required for a certain withdrawal in the future. Like maybe the problem we're solving is that, but sometimes we'll say like, well, you're going to receive $12,500 in 3 years. What is the equivalent cash inflow in year 0? Actually, most of the time in this class, we're going to be asking Excel to not change the sign. And so the built-in functions automatically change the direction from an inflow to an outflow. So we're going to have to manually override that in a lot of cases by putting a negative sign into the equation. So sometimes what we're going to be solving for is what's the present value of some future amount. That's the most common thing we're going to be doing. And so we have to manually put in a negative sign. So put a little note, a little warning to yourself that that negative sign in the pre-existing formulas is what allows us to maintain direction in the conversion instead of swapping the direction. That's one of like the mistakes that I see semester after semester is people forget to put in that negative sign. All right, so here's the in-class exercise, problem 3. We want to find out what's the present value of this cash flow. Like if you had to do this by hand, it would probably take a long time. It wouldn't be a fun problem. You could get the table and so like you could change this annual series to a future value, then move the future value to year 0. You could move all of these to the present. It would be a little bit lengthy. We're going to go over an easy way to do it in Excel. All right, so in your spreadsheet file, create a new tab at the bottom. Let's call this one problem 3, so P3. And up here at the top, I'm going to type in ICE in class exercise 7, problem 3. And you can't do this, but I can. I'm going to copy that image file, Control-C, and I'm going to paste it into Excel so that it's right there in my spreadsheet. Actually, you can do that if you like do a screenshot of the notes, but it's not as convenient as what I can do. Okay, the columns that we're going to put in is we're going to put in a cell where it's the interest rate. So I equals, and in this problem, the interest rate is 7%, so 0.07. And then we're going to have the column say time, amount, and PV of amount. All right, so time, let's translate that cash flow diagram into a cash flow table. So that's year 0 through 16. 16 is the last one that we have, so we have to have all the way through 16. And then just put the amounts in. Now this P is unknown, so the given value of that amount is 0. So 0, 0. We're just translating the cash flow diagram to a cash flow table here. Okay, so the function I'm going to put in is basically this formula, the same one we've been using so far today. P equals F times 1 plus I to the negative n power. But Excel has that already in its memory this way. You type in equals PV. That means find the present value. And then if you put in the parentheses, it's going to start prompting you on what it needs to see. So I open parentheses, okay, and it's saying rate. It needs to know the interest rate. So I'm going to click up here in the location where I have the amount of the interest rate, just the number. And then what do I need to do to make sure that it always looks in that same spot? F4. And what that's going to do is it's going to put in the dollar signs there. It's anchoring both the row and the column. Okay, so I've got the rate. Now, what does NPER stand for? That's an abbreviation that means what? The number of periods. So what it's asking is, okay, eventually I'm going to refer to this amount that's in that row. So NPER means how many years in the future is that amount? And so it's the time column. NPER is the time column. So the first 12,500 that we see in year 2, we want to move that 2 years to get to 0. So it'll be 1, 2 for that one. For this amount in year 3, how many years does that have to move back to get to 0? 1, 2, 3. So when I'm down here in that row 3, then n is always just going to be the time column to get it from wherever it is back to year 0. Okay, so NPR is number of periods. Now, what does PMT stand for again? Payment. This is another tricky thing, because if I refer to any amount in that PMT field, it's going to think that those are recurring payments, always the same amount. But that's not what we're doing. What we're doing is each row is an individual future amount. So this method is saying when we get to year 2, move just that 12,500, the first amount in year 2, back to year 0. And then when we get to another row, the row for year 3, it's moving that single 12,500 back to year 0. So we're skipping over the payment field. This is another one of those notes you need to put in the margin. Skip over the PMT field. So you put in a double comma to skip over it, because that amount is not a recurring ongoing payment. That's just a single amount, and there may be some single amounts that have the same quantity, but each one of those rows represents just a single payment, one time, not recurring times. So here where it says future value, that's where we put in a negative sign and click on the amount. Why the negative sign? Right, because Excel, just by convention, it flips the direction of the amount. And we don't want to flip the direction. We want the direction, an inflow to stay in inflow, and an outflow to stay in outflow. So we have to kind of manually override Excel's assumption on that. Okay, so you type enter. Of course, it's going to be 0. And let's highlight all of these and turn it into currency. So home, currency, and decrease the decimal just so there's less nonsense on the page. Okay, so now we can drag that formula all the way down through, and let's see if the numbers are making sense to us. Like, is the trend reasonable? So 12,500 in year 2, if you move it to 0, it's equivalent to 10,918. But then this amount in year 3, it's worth less than the amount in year 2 was. You should be able to explain concepts on the quizzes. Like, I'd say, why is the amount in year 3 worth less than the amount in year 2? And the reason why is year 3 has more years to discount. And so it's discounted more years, and so its value is less in present terms. Okay, so what we need to do now is sum up all of these values. And so the sum of the present values, so sum, and then highlight all of these. And that tells us that the sum of the present value is 78,000. And let's see, what was it asking here? For the cash flow diagram below, solve for the present value. So what we're saying is, if you have an environment where the interest rate is 7%, getting $78,000 in year 0 is the same as this cash flow diagram. Like this series of payments and one outflow, that cash flow series has a present value of 78,261. Is there anything you'd like to see me do again? Anything that you weren't clear about, that I maybe jumped over too fast? All right. Well, with Excel, there's usually a faster way to do something. And on this problem, the faster way to do something is a function that's called NPV, net present value. And here's a warning about net present value. Here's the formula. You're going to use some interest rate and a range of values in the future. So I've underlined it, bolded, and I've put a lot of exclamation points here just to emphasize that inside this function, the range of values should only include future amounts. It shouldn't include any amount that's already in year 0. So let's see how this function works for this one. The way that we would find the net present value of this cash flow diagram, so here I'm going to have NPV. So it just is meaning the result of the net present value function. So equals NPV and the rate. So I can type it in or I can click in the cell location. So it was 7%. Now comma. Now it needs to know all of the values. If I start here at the top and include the amount that's in year 0, I'll get the wrong answer. So I need to skip over any amount that's already in the present, because what this function does is it converts future amounts to the present. So only put something into that function if it's not already in the present. If it is in the present and you put it into that function, then the whole thing is screwed up, because it's expecting to see like amounts and the order of the amounts, and the first number it wants to see is what's in year 1. It doesn't want to see what's in year 0. That's how Excel's been programmed. And so I'll click only that range of values that's in the future, and then I close the parentheses, and I externally add the amount that's already in the present, outside of the formula. So the total present value is going to be the amount that's already in year 0, plus all of these future amounts that have been converted into a present amount. And as soon as I press enter, hopefully it'll give me that same 78,260. So Right, 78,261. So it's the net present value. So what it's doing is it's automatically converting from future values to the present. I'll remind you that you should have your cell phones put away during class, that those shouldn't be out and you shouldn't be texting during class. All right, so any questions about this one? Net present value. By the way, let's just see if we forgot that rule. Equals NPV, and the rate is 7%. And what if I put the entire cash flow? So some of you, unfortunately, will make that mistake, and it'll cost you points on exams or quizzes or homework. Some of you will make that mistake because it gives you the wrong answer. What it did, if you have the whole range in there, remember, it's expecting that the first number it sees, it's expecting that that's year one. And so all of the others come at the wrong time. If you screw up the first value, every other value after that's in the wrong spot. So you can only have it be the amounts that are already in the future. So the future amounts, and then outside of the function you add what's already in the present. That's the right way to do it. All right, so here's the last one of the day. I'm going to pause from talking and give you a chance to set this one up and try and figure it out yourself. I give you a hint. On this one, we want to find what's the future value of this cash flow diagram. So you need to have the following columns. One column that's years, another column that says years until year 16. And so you're going to kind of like reverse your time. And then you'll have a column that's amount, and one that's future value. And so there's a function out there that's future value, and it works essentially the same as the present value function is. You're going to have to use a negative sign in the same way that you did. You're going to have that payment field skip over it with a double comma to skip over the payment field. So I'm going to stop talking, give you a moment to set this up, and then we'll work through it together. Okay, I've got the solution up on the screen if you want to compare what you've done to the answer. I'll circulate around for a minute here and then we'll go over the solution on the screen. Now, if you didn't quite finish, of course, you can continue to work on this. Be sure to save your file and you can come back to the recording if you need to. So the reason why we have this separate time column is that n is different from the year that it's in. Like the amount that's in year 0, we're not moving that 0 years to get it here to the end of the cash flow diagram. We're moving it 16 years to go from 0 to 16. So we need to have an alternate time column that tells us how many years is it moving from where it is now to where we want it to be. So since we're doing it to the future, we'll create that alternate time column. The amounts are self-explanatory, so let's go over the future value function. So the way the future value function works is equals FV, parentheses. Now it wants to see the interest rate, so I'll click on the location for the interest rate, and I'll push F4 to lock it in place. Now for NPER, use that alternate time column that you've prepared. Years until year 16. Okay, double comma to skip over the payment field. These aren't recurring payments of the same amount. It's individual amounts that we're moving one at a time into the future. And then for the present value, we need to have the negative sign and then click on the given amount. So that tells you that the 10,000, if you move it 16 years in the future at 8.5%, it's going to be worth 36,000 in that future year. And we apply the same formula to all of them, and it sums all of the future values. So each one of them individually has been converted into an equivalent amount in year 16, and the sum of those equivalent amounts is 3,821. Unfortunately, that's all the time we have for today, so let me just very briefly refer back to these announcements that your homework assignment is due a week from today. Quizzes may occur at any time, hint, hint. And bring your laptop to class on Thursday. All right, I'll see you then. Have a good day.